Translations. The objective of this video is to identify and graph translations of parent functions. Now that we know what parent functions are, we can perform translations. So we have two types, a vertical and a horizontal translation. This basically means either we're moving our graph, we are shifting it left or right, or we're moving it up and down. The shape of the graph does not change. It stays exactly the same. We're just literally moving it. So when we have a function, doesn't matter what parent function it is, if we are adding or subtracting k, so that means we're not actually affecting the graph, it's the y value, we're not affecting the x value, it's just on the outside. This is going to be a vertical shift, so we move it either up or down. Now, if we're actually affecting the x value, so this is up or down, so if we add or subtract something directly to the x in the function, then this would be left or right. So the first key is to identify your parent function. So in this case, my parent function is x squared. I want to plot some of the points of my parent function, maybe using a different color, in order to be able to just shift the graph later. So first I'm going to pass my parent function, which goes through 0, 0, 1, 1, 2, 4, negative 1, negative 1, negative 2, 4. So this will be my parent function, this parabola. Now it says x plus 3 in parentheses squared. Because the 3 is inside the parentheses, it is directly affecting the x, which means this is going to be a horizontal translation. Because it says plus 3, I'm going to follow my image on top. When it's plus, we're actually going to go left. So I'm going to take every point and shift it 3 points. So 1, 2, 3, 1, 2, 3, 1, 1, 2, 3, 1, 2, 3, 1, 2. So now my image in red is my new graph of my translation. So again, we want to do the same idea, identify the parent function and plot your parent function to help with the translation. So this is an absolute value. So 0, 0, 1, 1, 2, 2, 3, 3, etc. So this one is a V-shaped as opposed to my U-shaped. Now my number, -1, is on the outside. It's not directly affecting x. So this is my k. Because it says -1, we're going to go down 1. So each point is just going to go down 1 point previous than before. And the red image is my parent, my new function. You want to take a minute, try and draw the transformations of this graph, and then press play to see if your answer is correct. Pause your video now. So this is my square root function. So I'm just going to draw my parent function, the square root of 0, 0. The square root of 4 is 2. Square root of 9 would be 3. So I only have 2 points to really use in my translation here. So this is on the outside, meaning it's not directly affecting x. So this is affecting a vertical. Because it's -2, we're going to go down 2. So every point I plotted originally will just go down 2, but it'll stay in the same shape. Now, my parent function in my second one is a reciprocal function. So that one has the invisible walls. So I'm going to do my invisible walls, my asymptotes, with these yellow dashed lines. And then my parent function, 1 over 1 just gives me 1. And then everything else is just getting smaller and smaller. It's important to know what your parent functions look like so you can estimate using just one of the points. And now I'm going to identify what kind of translation this is. So it is directly affecting x. So this is a horizontal translation. And because it's +2, we're going to go to the left 2. So this means that my asymptotes also change. My asymptote will also shift. So before, my vertical asymptote was at 0, and now I'm going to move it to the left 2. But my horizontal asymptote stays the same because we're not shifting that. The points will also shift to 1, 2, 1, 2. And they will approach the yellow and green asymptote in this case. For these type of problems, we're doing a sketch. We are not trying to get an accurate picture. We just want to have idea of what these images look by just looking at them, which is why we are practicing this skill.